Hello my friends, welcome back to our YouTube channel. In our video today, we're going to show the build of this compact 12 volt 4S lithium phosphate battery pack. The goal of this design is to validate the cells that I'm going to use for my next project, which is this pack over here. So my next project will be a solar generator. So in order to do that, I went ahead and ordered a few samples of these 32700 battery cells. I wanted to test them to make sure that they will perform as promised. The ones I am using are 32700 battery cell, and that kind of shows the size. They are almost the size of a D cell battery, and they're rated for 7000 milliampere hours. So these batteries, you can charge them with about 3 amps of charging current, and you can discharge them with a maximum discharge current of about 30 amps. The manufacturer of this product, cell, promises about 2000 cycles, which means you can charge them, discharge them about 2000 times, which is, they can last so many years depending on your usage. So, and because I have my power inverter that I'm going to use to test this out is a 24 volt inverter. I had to build 2 of this to make sure that I can drive them, test them at 24 volts. So, but each of these cells are 4S, meaning you have 4 of these cells, Lifepo cells in series. So to give me 12 volts and 12 volts. I could have possibly used one PCM here, one 8S PCM, but this was what I had, so I decided to use 2 PCMs. So now a little bit about the battery PCM. This is a 4S 12 volt PCM that's rated for 100 amps, meaning that it should be able to, at full charge, be able to allow this battery to push out 12 volts at 100 amps. So it can actually support a lot of load, no issues. And it has an overcharge protection of 3.65, meaning that if these cells charge up to 3.65, the PCM will cut off. And it has also a discharge cutoff of 2.65. So if you're discharging it, 2.5. If you're discharging it below 2.5 volts, then the PCM will also cut off to protect the batteries. So a little bit of a safety tip here is to make sure that when you're doing this, when you get to a point in the build, make sure you cover the tabs, the exposed tabs with, here I use electrical tape to make sure, because these batteries are high energy density batteries, so they can actually cause fire. So be aware of that if you're able to, if you ever need to build something like this. So lastly, let's do a voltage test on these units to see how they perform. The battery is right now is about 50% charged. So let's measure the voltages and see what we get. So right now, these batteries, when they are fully charged, as you can see on the multimeter, when they are fully charged, you would expect to see about 14.4 volts, which means 4 of the batteries in series. So we are seeing 13.14 volts because they are kind of about 50% charged. So they are not fully charged. And again, because I am using them for a 24 volt application, I have to connect the 2 12 volt packs in series to give me 24 volts. So let's check out how many volts we have with these 2 in series. So as you can see, I have the batteries hooked up in series, 12 volt, 12 volt, but when they are fully charged, you have 14.4 and 14.4. So the two batteries should give you 28 volts. And then, as you can see in the multimeter, we are getting 26.2 volts, which is still able to drive our 24 volt inverter. So next in the video, I'm going to be showing the process of actually building a battery pack like this, showing you how to connect the PCM, and that's pretty much it, how you can stack the battery, connect the PCM, and there you have it.